Assalamu alaikum and welcome back. My name is Sarem Ahmed Khan and I welcome you to my YouTube channel KhanKnowledgeBase. This is our first lecture and we are starting with one of the most important topics in physics, simple harmonic motion. I will be explaining all the topics with example to you. If you enjoyed this video, don't forget to like, share and subscribe to stay updated with upcoming lectures. So our first chapter is simple harmonic motion. Now, what is simple harmonic motion? Simple harmonic motion is a special type, or you can say a special kind of a vibratory motion. Now, there's a question that what is vibratory motion? A vibratory motion. A body is said to be vibrating if it moves back and forth or to and fro about a point. Now, for example, spring mass system, guitar string swings. Now, we can take the example of guitar, a wide stretch, a wide stretch between two fixed points. When plugged, it start vibrating to and fro. Most of the musical instruments like guitar, sitar, etc. have a string attached to them to produce music by creating vibratory motion. Now take a step further, that simple harmonic motion. Simple harmonic motions occur when the net force is directly proportional to displacement from mean position and is always directed towards the mean position. For example, as you can see in the picture, a child sits in the swing. When you pull it back and release it, the swing moves forward and backward rapidly. This kind of motion is called vibratory motion, and when the motion is happen in such a way that the restoring force is always directed towards the center and the proportional to how far the swing moves, then it becomes a simple harmonic motion. There are three conditions for simple harmonic motion. Condition for simple harmonic motion. Acceleration of a body must be directly proportional to the displacement from mean position. This means that when an object moves away from its central position called mean position, the acceleration it experiences is proportional to how far it has moved its displacement, but the acceleration always points back towards the mean position. In other words, the further the object moves away, the stronger the acceleration pulling it. The second condition is that acceleration of a body should be directed towards its mean position. In this case, motion is called restoring force. Now, what is restoring force? The force always pulls or pushes the object back towards its mean position. For example, if you pull a spring to the right, the spring pulls it back to the left. If you compress it to the left, it pushes back to the right. This restoring force is responsible for bringing the object back when it moves away, causing the repetitive motion. The restoring force is directly proportional to displacement and directed towards its mean position. As you can see, acceleration is directly proportional to the negative displacement. The negative sign shows acceleration always acts opposite to displacement, pulling the object back towards the center, or you can say pulling back the object towards the mean position. In short, acceleration is directly proportional to displacement but point in the opposite direction. The third condition is that the system should be frictionless and the body executing simple harmonic motion and have inertia and restoring force. For any object to perform a perfect simple harmonic motion, the physical conditions must be satisfied. Number one, the body should be frictionless. Number two, the body have inertia and also restoring force. For example, the ball and the ball system at position O, the ball get maximum speed due to inertia and move towards the extreme position B. While moving towards the extreme position B, the speed of the ball decreases due to restoring force which decreases due to the restoring force which acts towards the mean position. At the position B, the ball stops for a while and then again move towards the mean position O under the action of restoring force. These to and fro motion of a ball continue about the mean position O till all its energy is lost due to friction. Thus, the to and fro motion of a ball about a mean position placed in a bowl is an example of a simple harmonic motion. Now, further, we can move toward an example of a simple harmonic motion, which is motion of a mass attached to a spring. Now, as we study in class 9th, Hooke's law, the force that is applied to a spring is directly proportional to the displacement. This law states that you pull or push a spring, the force extract to return to its original position will be directly proportional to how much you moved it from that original position. As you can see in the image, in this image the spring is at original position. Spring is at original position. It's neither stretched nor compressed, therefore no force. F equals to 0. F equals to 0 is acting on it, and its displacement is x equals to 0. Now we can move towards the next slide. As we know that from Newton's second law, F equals to ma, force equals to mass multiplied by acceleration, and always know that the spring is an elastic according to Hooke's law mathematically. F equals to minus kx, where k is the spring constant and x is the displacement covered by an object. Comparing both equations, we got ma equals to negative k or x, where a equals to negative constant divided by mass, where k is the spring constant, m is the mass constant, and a is constant for displacement. For this we got, for this mathematically we got this expression, where this expression means acceleration is directly proportional to negative displacement. We can prove this. Mm, Now, what is the restoring force? As we can discuss, it's our earlier slides. When an external force applied on a spring, its length increases after releasing the spring. Will move towards the mean position is due to a force which is called restoring force. For example, when a metal rod is struck, it being to vibrate. These vibrations are due to restoring force act on the particles of a material. As the particles are displaced from their equilibrium position, a restoring force pulls them back. This back and forth motion is an example of simple harmonic motion. Eventually, the vibration becomes smaller as energy is lost due to surrounding and the rod returns to reset. I hope everything was clear and easy to understand. That's all for today. See you in the next video with the new topic. Until then, take care and Allah Hafiz.